Hello, my name is Mike Steele. I'm an associate professor in the Department of Animal Biosciences at the University of Guelph, and I'm going to discuss new concepts in calf nutrition and really focus on a lot of the research that we've been publishing in our lab over the last 5 years related to calf nutrition. So first, I want to discuss why I think early life nutrition is important in the dairy industry, and then discuss some of the most recent research related to colostrum, milk feeding, as well as weaning strategies. First things first, let's talk about early life nutrition. So the idea of early life programming and how nutrition and how you feed this calf in the first days of life and even in the first months of life can have a long-term impact have really come from a lot of research from Cornell University, which showed this relationship between average daily gain pre-weaning and lactation performance. So relationships of 1 kilogram of pre-weaning average daily gain being equivalent to 1,500 kilograms more milk in first lactation. So if you boost your average daily gain, you can expect these cows to produce more later on in life. So this was a big movement and really encouraged a lot of dairy farmers to spend more time and actually measure average daily gain during the pre-weaning period. So a lot of my research, and this is all my research questions come from dairy farmers, are really related to colostrum management, plenty of nutrition, so how to feed milk, also how to feed concentrates. I've also done a lot of work related to what antimicrobials do to the calf and what are the alternatives to antimicrobials. And more recently, I've been doing a lot of transition cow work and then looking at the impact on the calf. So for today's presentation, I'm going to focus mainly on colostrum and plain nutrition. But all of this research comes from my NSERC Industrial Research Chair, where I initiated this at the University of Alberta with Alberta Milk and also Lalaman Animal Nutrition and the Western Milk Boards. But 2 years ago, I moved my NSERC Industrial Research Chair right here to the University of Guelph with the support of Bayer as well as Trow Nutrition. So I still have one more year left in our program. It's been amazing. I've been in contact with over 50 students in this program. And since April 2016, we've published over 50 peer-reviewed papers related to calf nutrition. So really, really proud of my group for all the accomplishments. So some of the accomplishments from some of the first experiments we've done are related to colostrum, and we've published about 10 papers related to colostrum nutrition in the Journal of Dairy Science over the last 3 years. A lot of our work is looking at other bioactives in colostrum. Now, obviously immunoglobulins are really important, but there's hundreds of other bioactives within colostrum, like hormones, different fatty acids, different oligosaccharides that are all contributing and the calf really requires in this colostrum. That's why the dam is creating it. But we don't really know what they're doing in this calf metabolically or from a physiological standpoint. So we've been doing a lot of work in this area. We've been looking a lot at insulin recently with an experiment that we just finished and many more. Where we spent most of our time, though, since the beginning of this research program has been looking at colostrum oligosaccharides. So colostrum oligosaccharides, instead of lactose in colostrum, we have a lot of these oligosaccharides which act as prebiotics. And there are differences between multiparous and primiparous. But what was really interesting is that they're very high in the first milking, being the colostrum, but they're also high in transition milk, being the second, third, and fourth milking. And we're noting that a lot of these bioactives, being proteins, fats, or these oligosaccharides, are also high in that second, third, and fourth milking. So it makes me question the way that we've been feeding colostrum, typically focused on passive transfer of immunoglobulins, feeding 1 or 2 meals, then a quick transition to a milk or a milk replacer, rather than this gradual transition, which you would see in nature. Which leads me to an experiment that we did that we just published in the Journal of Dairy Science, where we fed all calves 1 meal of colostrum, and then we followed them with an abrupt transition to milk, or we put them on 50% milk, 50% colostrum. We're terming this transition, or we kept them on colostrum. And at the end of the 3rd day, there was large differences between milk and the other treatments. So this abrupt transition from colostrum to milk depresses gastrointestinal development. The villi growth is really depressed in this group compared to the other 2 treatment groups. So you want to develop this gastrointestinal tract so these calves can absorb a lot of nutrients during this time. So this would really go to show that transition milk does have a benefit with respect to the gastrointestinal tract development of the calf. Now, where we did a lot of calf research only from the beginning was looking at milk feeding levels, and we've tried to determine what genes are being turned on and off in calves through feeding high or low levels of milk. We've been doing a lot of work with feeding calves higher levels of milk in the first 3 weeks of life in particular, which sometimes is depressed even if we do bump them up in milk. Now, a lot of this work is using automation, and here's some of the results from an experiment. This is at the University of Alberta, where we compared 5 versus 10-liter feeding. You know, you're going to get more growth if you're feeding more milk during this time when they're not consuming significant amounts of starter, which is week 1, 2, 3, and 4, as you can see. That's where you're going to get the biggest difference here. Now, even with feeding 2 times a day, you can still do this. You can feed up to 8 liters a day at 150 grams per liter. That's not a problem based on some of our research that we've published. But where our research is really heading is looking at milk composition. Now, in particular, the differences between milk replacer and whole milk from a composition standpoint. Now, I am not against feeding milk replacer. I think it fits very well in many scenarios. But what I do have is a question about certain companies having a little bit higher lactose concentrations compared to whole milk, and also the fat being lower. Not to mention the ash is also higher in a lot of milk replacers, and we're doing some research in that area. But where we've started our research is looking at this difference in lactose and fat and what this is doing. So we know that the osmolarity will be higher in a milk replacer. It's typically over 400 because of the high lactose as well as the ash. And what my PhD student just published just prior to joining my lab, showing that hypertonic milk replacers actually increase gut permeability in these calves. And my PhD student, another one, published this work showing that higher lactose results in increased gastric emptying and lower glucose tolerance in the first week of life. When you're feeding these milk replacers high in lactose, it does show a reduction in glucose tolerance. So this is interesting. What are the long-term implications of this research? We don't know at this point, but we're just looking at proof of concept right here, and we're eventually going to be following these animals for the rest of their life and looking at overall performance. So I'd like to conclude this presentation looking at some of the work related to weaning strategies. Now, we've done a lot of work in our lab characterizing the rumen. We've fistulated calves, newborn calves. We've characterized the structure and also the microbiology in great detail with different weaning protocols. But it really led us to think that we should be spending more time on the lower gut. And I mean the small and the large intestine when we look at weaning, and also transition cow health. But that's another story for another presentation. Now, what concerns me most is that we have not only big ranges in our milk replacer composition in the dairy industry, but also our starter starch compositions. They can range commercially between 10 and 50%. And I think a lot of this bypass starch goes to the colon, and we get a hindgut acidosis. So a lot of our work has been looking at characterizing this hindgut acidosis in calves and seeing if it does contribute to the depression and overall growth. And this has led us to the question is, should starter composition be tailored for the milk feeding program? And the more and more we do work in this area, and this is some research that we did last year in Ohio, just showing high and low milk replacer feeding and high and low starch starter composition, just showing the average daily gain that there are some interactions here. And we're just going through this data. We're looking at continuous ruminal pH data and gastrointestinal function. But there looks to be some interactions which suggests that the milk feeding program should be tailored to the starch feeding program. But this is requires a lot more research. Another area that we're getting into is this big black box that we need to shed light into of what to do and how to feed calves between 2 months and 22 months. And I think that we should be starting to integrate this. Now, we've been only doing research up to 6 months in our lab, but we need to do something about this black box. And we need to do this at Elora. We need to get feed bunks in that heifer barn, and we can take off and really, really develop a lot of great research in this area. So I look forward to doing that. To conclude this presentation, I really need to thank my lab. They've been spectacular. They've been through a big transition from Alberta to Guelph, and they've done amazingly well. I'm really proud of some of their accomplishments this year, and also the wonderful team of CAF researchers we have at the University of Guelph, Doctors Dave Renaud, Charlotte Winder, Trevor DeVries. It's amazing to be in a productive group, and this year in 2020, we're publishing 50 peer-reviewed manuscripts related to CAF research, which is truly outstanding. And I'm so happy that I had the opportunity to work with these great researchers. So thank you very much for your attention. And I really look forward to the discussion associated with this presentation. Thank you.